Hey, what's going on? In this video, I'm going to be forging out a set of 3 kitchen knives from ADCRV2 steel. I'll be making a 9-inch chef knife, an 8-inch fillet knife, and another smaller 7-inch chef knife. I typically forge several knives at once, but they're usually similar blade profiles. Forging different styles of knives like the knives in this set at the same time is actually really difficult for me. A chef knife is kind of my bread and butter. I make a lot of chef knives, but forging a fillet knife with a brute to forge finish is pretty intricate work, and it's difficult mentally to think about what needs to be done on each knife during each heat. I start out by forging in the tip on the press, and I like to use a rounding die on the top and the larger flat monstrosity that I made on the bottom. This allows me to keep the edge more or less flat as I taper the tip down. I use the press to do the heavy lifting, and then I refine the shape on the anvil. Throughout the video, I'm going to be bouncing between footage of all 3 of these knives. It would get pretty redundant to show all of the build steps for each knife. Here I'm using a flat die on the top of the press to isolate the material for the handle. I like to use the cross peen of the hammer to shape the front finger choil, or the area where the handle transitions into the blade. You do need to be careful of any cold shuts you could introduce by forging over these creases left from the press. It's a good idea to go over the whole area with a grinder after forging. Now I'll use some rounding dies to draw out more length in the handle. I'm working on the fillet knife here and drawing out more length in the blade. Fillet knives need to be extremely thin to work well. I probably should have just done this with the hammer, but the fillet knife was getting a little too tall, so I pressed down the profile, which also added some length to the blade. Now I'm working one of the chef knives and drawing out more height in the blade with some fullering dies. The fillet knife is coming along, and I'm starting to hammer in the bevels. I ended up with a bit of a humpback on the chef knife, and a way to flatten that out and also move the orientation of the handle up is to hold the handle and smack it on the anvil. If you end up with not enough material in the heel of the blade, this is a nice way to add more material down there. I clamp the knife in a vise and use the cross peen and drive it down into that finger choil. It's going to want to fold over, especially if it's really thin, so you have to work in small chunks here and go back and forth to the anvil and straighten everything out. Now I'm going to start forging in the bevels on the chef knives. I didn't have quite the profile I wanted, so before I forge those bevels too thin, I refined the shape on the anvil a bit. And now back to thinning out those bevels. After the blades were rough forged to shape, I let them cool slowly overnight in the forge to anneal the steel. This will soften the steel to make drilling and grinding a lot easier. You can see I sharpied in what I wanted the profiles to look like and refined the shapes on the grinder. Now that the blades are profiled, I'm going to mark out some holes for handle pins. In addition to the 3mm holes for the pins, I'm also going to add several larger holes for weight reduction and also to allow the epoxy a channel to bond through the tang and to the scale on the other side. I chamfer all the holes to reduce the risk of a hard 90-degree edge causing a crack during the quench. Now that the knives are all profiled, I'm going to stamp them with my maker's mark. I get asked a lot where I get my hot stamps, and I get all of them from Steel Stamps Inc. Since these are almost ready to heat treat, I like to do a thermal cycle or two where I put the blade in a vise between two pieces of angle iron and let it cool to room temperature to get it as straight as possible. Here's a look at all three knives before we start the heat treat process. I'm going to be running 3 normalization cycles at 1650, 1500, and 1400 degrees Fahrenheit. Each cycle I let the blades cool to room temperature in open air. This is the heat treatment recommendation for ADCRV2 steel in the book Knife Engineering by Dr. Laren Thomas. It is an awesome resource that covers a really wide range of steel topics that are all super relevant to knife makers. Definitely recommend getting it. I'm quenching all 3 of these knives at 1525 degrees Fahrenheit in Parks AAA quench oil that has been heated to around 120 degrees Fahrenheit. After I quenched each knife, I allowed the kiln to get back up to 1525 for a 10-minute soak before quenching the next knife. Another thing to keep an eye on is how hot your quench oil gets between quenches. The high end of the recommended range on Parks AAA is 150 degrees Fahrenheit, so you'll want to make sure you don't get any hotter than that when quenching. One of the nice things about having a larger volume quench tank is that the overall temperature doesn't change a ton with each knife that you quench. You see much more dramatic changes in temperature with tanks that hold less than a gallon of quench oil. This one holds about 3 gallons. I tempered the 2 chef knives at 400 degrees Fahrenheit and the fillet knife at 425 degrees Fahrenheit. If you have one, a granite surface block is great for making sure things are flat, but they're pretty expensive. I find that this leftover floor tile works pretty well for prepping handle scales for epoxy. While the blades are in the oven, I'm going to epoxy the G10 liners onto the handle scales. I clean every surface well with acetone, and I'm using Total Boat medium epoxy. Generally, I add black color pigment if I'm using black liners, but I think clear works better with white liners. Now that the knives are out of the temper oven, I'm going to hit them with a wire wheel to remove any remaining forged scale. If you don't want to use a wire wheel because it's kind of dangerous, you can just soak the knives in high concentrate vinegar overnight, and that will dissolve most of the forged scale. After that, you can just give it a scrub with a soft wire brush by hand. I grind in the bevels with a 60 grit ceramic belt, and for that belt I like to use a guard to make sure I don't encroach on the part of the handle that will be covered by the scales. Between the 120 grit and 220 grit belts, I like to test the edge for hardness with this set of Rockwell hardness files. I do this at this point because it ensures that I've ground through any decarb layer, and it's still pretty easy to smooth over any surface scratches from the files with the 220 grit belt. I would guess that both of the chef knives were around 61 Rockwell, and the fillet knife is around 58 or 59 Rockwell. The handles on the 2 chef knives felt slightly on the small side, so I ground in about an extra ½ inch. After taking the bevels up to 220 grit on the 2x72, I moved over to hand sanding and went back down to 120 grit. Between each grit progression, I like to change the direction that I sand in. This is such a valuable tip for making sure that you get rid of all of the previous grit scratches before moving on to the next grit paper. To give you an idea of how thin I took the edge down to, you can see the deflection in the steel as I slide my fingernail along the edge. Once I get to 400 grit, I switch over to a cherry wood sanding stick, and I finish with long continuous passes to remove any J-hooks in the finish. Now I'll cut 6 3mm stainless steel pins for the handle and clean up the edges. If you're looking for any of the tools and materials that I use in my videos, you can find links to most of them on my website, davidmanforge.com, under the Product Links tab. I like to place the handle pins in the material as I'm drilling out the rest of the holes. I'm going to sand the fronts of the scales up to 600 grit and then polish them on a buffing wheel with pink rouge before attaching the scales. With the Brute deforged finish, I like to scuff up the surface of the tang with 120 grit sandpaper before gluing up the handle. It was pretty cold here in the shop, even with the heaters on, so I was struggling to get the epoxy out of the pump. One of the most important things you can do to get a strong bond with epoxy is to have a clean surface. Everything was sanded to 120 grit and then cleaned with acetone before applying any epoxy. I got the blade clamped up and took it inside to cure overnight. Now on to the next knife. I already ground the bevels up to 220 grit on the belt grinder, and before moving on to hand sanding, I like to clean the forge texture with a soft wire brush. This ensures that I get any faint rust or grime from grinding off the knife. We'll kind of breeze through sanding on these other two knives since it's more of the same from the first knife. I did a full flat grind for the majority of the bevels on the filet knife. This creates a much thinner and more flexible edge geometry. Now that the epoxy on all the knives is cured overnight, I'll get to work on shaping the handles. I get everything profiled to match the contours of the knife, and then I start to shape them freehand. I took all of the handles up to 600 grit before polishing them on the buffing wheel. In case you're wondering, this is how I cut my 1.5 inch strips of sandpaper. I felt a really faint crease in some sections of the junction between the tang and the liners on this knife, so I added some Starbond CA glue with instant activator to make sure there wasn't any possible little gaps for moisture to get into. It hardens almost instantly with the activator, but I usually let it sit for about 15 minutes or so before sanding. I also found a small void in the maple burl on this handle that I wanted to be sure to seal as well. This is the medium thick star bond. I find that the thin version just runs way too much and the capillary action just pulls it everywhere. I normally finish the spine of the knife before I attach the handle, but for some reason I convinced myself it would be easier to do after the handle was on. It seems like I do this once a year or so and then remember that it's super stressful to do this to an almost finished knife. It's just way too easy to mess up the finish on the blade or the handle at this point, so I would recommend doing this earlier in the process. Here's a look at the handles after they've been sanded to 600 grit and polished on the buffing wheel. I apply 3 coats of Odie's oil and allow for at least 12 hours of cure time between coats. I'll sharpen these knives on diamond stones and progress through a 300 grit, 1200 grit, and 3000 grit stone. Next I hit them on a double-sided leather strop that's loaded with 5 micron diamond paste on one side and 3.5 micron diamond paste on the other side. You may have noticed that I sliced my thumb while wiping one of the blades, but nothing that a paper towel and some painter's tape can't fix. I swear that's the only time I ever cut myself anymore is when I'm wiping down a blade after I've just sharpened it. We'll do some fun little cut tests and slice some paper towel rolls and some printer paper. This fillet knife is an absolute laser. I apply a food-safe blade wax to help protect the blade from moisture and bacteria, and then I melt it with a heat gun to make sure it seeps into all of the crevices of the brute de forge finish. Here's some finished shots of this set. Let me know what you think in the comments. Thanks for watching.